I have something like 2x squared plus 4x, and I tell you to divide it by 2x. This is my example. This isn't in the book. You look at each term individually and see if it is divisible by 2x. It would look something like this. 2x squared over 2x plus, since it's a plus, you carry that over here, 4x divided by 2x. You guys seeing what I'm meaning here? What is the result of any number divided by itself? 1. X squared divided by x to the first. Does anybody remember what that would be when you're dividing? X. If you are dividing a variable, you simply subtract the exponents. So that would be x. 4 and 2. So 4 divided by 2 is 2. Any number divided by itself is 1. And remember, this is 4 times x, so it now becomes 2 times 1, otherwise known as 2. Right? You guys with me so far? Okay, so that would be the answer. All right? Example 1 is another very simple version. Take a look at it. I'm not going to necessarily do it, but take a look at example 1. Example 1 is 5m plus 35 over 5. Okay? So 5m divided by 5 is m. Does everybody see that? If you're looking in your book. 35 divided by 5 is 7. If you need to borrow a textbook or look on, okay? I want you with me. All right. Now, we are always going to assume, and this is very important that you recognize this, no divisor, that's the thing on the bottom, equals 0. All right? Because if I assume that, then this division makes sense. But if I assume that x is 0, then somehow I end up with a convoluted mess. Okay? No divisor ever equals 0 whenever I'm asking you to perform division with a variable. Okay? Let's look at example 2. Continuing the same process, they only get more difficult or more complex, but the technique remains the same. Okay, the way we have it written in the textbook looks like this. But we're going to break it apart and take 26uv divided by 13v and subtract it from 39v divided by 13v. Okay. Numerically, 26 divided by 13 is 2, right? Now, u has no matching u underneath, which means you assume or you take it to mean u divided by 1, which is u. Okay? V divided by v is 1. So you don't have to write 2 times u times 1. Everybody with me? 39 negative divided by 13 is a negative 3. V divided by v is 1. I'm not going to write 3 times 1. I'm just going to write 2u minus 3. Example 3 is a little more complicated, as is the rest of the lesson. But again, it's the same technique. You just have to maybe slow down, use a little more paper. Example 3 is a little bigger. Instead of having only 2 terms in the polynomial, we now have 3 terms, which makes it a trinomial, by the way. 3x to the 4th minus 9x cubed y plus 6x squared y squared. All of that is being divided by negative 3x squared. Now notice how I rewrote it this way. You don't have to do that if you can do each piece in your head. Okay, I don't care how you do it. Okay, if you're going to do it writing it out, 3x to the 4th divided by negative 3x squared minus, so that's a negative 9x cubed y over negative 3x squared, positive 6x squared y squared divided by negative 3x squared. The reason I'm making a stink out of this one is because you need to be very careful about your positives and negatives here. A 3 divided by a negative 3 is what kind of 1? Bravo. x4, x2, x squared. And you don't necessarily have to write that negative 1. You could just write negative x squared. Okay, does that make sense? This negative applies to the 9. Negative 9 divided by negative 3 is what kind of 3? Positive. Bravo. X cubed by x squared, x. Y divided by 1, looks like that. Positive 6 by a negative 3 is a negative 2. X squared by x. Y squared by nothing. Oopsie, yep, you're right. X squared by x squared, thank you. Okay, so your answer is going to look like this. If you were to check in the back of the book for the answer, it would not have the negative 1. It would look like that. Okay? Dividing positives and negatives throw a little bit of a wrench into the chain that you have to make sure you do properly. Okay? Okay, next one, example 4. Example 4. You learn when you're dividing with variables, you simply subtract the exponents and you keep the value. If it's larger on the bottom, you make that the denominator. Well, that's going to come into play here as I illustrate real quick. So it's written like this. We're going to rewrite it. X cubed y over x, y, negative 4x divided by positive xy, positive 6y divided by xy. Okay. X cubed x squared. Y cancels itself out because it's a 1. Negative 4 divided by 1 is a negative 4, right? X cancels itself out. Nothing, which means you have to think of it as a 1. 1 divided by y is 1 over y. Okay, there's nothing to divide that y into, which means the y stays right where it is in the denominator. Okay? And if you think about it, it makes sense. What I just said here by writing 1 over y is the fraction 1 over y. Okay? So 4 times 1 is 4 over y. Okay? The next one is about the same. Positive 6 divided by 1 is 6. There's nothing there to divide the x into, so call that a 1. 1 over x, the x sits down below. Y divided by y is 1. Okay? Again, in the example here, if there is nothing to divide your denominator into, it simply stays in the denominator because it's 1 divided by x. Still the same. Okay? 1 divided by x. Okay? Example 4. Example 5. Trying to see how far I need to take you. Yep, I need to keep going. This is super, super easy. Example 5. This looks scary. Oh no, factor. No big deal. 5x squared plus 10x. What it's telling you is break it into the factors that when multiplied would create that as a product. First thing, look for a common factor of both monomials. What do 5 and 10 have in common? 5. X squared and x have in common? X. Okay, so we just basically identified the greatest common factor. Okay? That's the greatest common factor. If I divide 5x squared by x, I end up with x, don't I? If I divide 10x positive by 5x positive, I end up with a positive 2, don't I? Okay, so all I did, folks, is find out what they both had in common, which you all said was 5x. I divided both pieces by that number, and then listed what the end result was as the other factor. Okay? 5x times x plus 2. Okay? First we identified the common factor, then we divided out, so to speak, the GCF. The next step was the quotient is the other factor. Okay, we divided out the GCF. The quotient is the other factor. Okay, 5x, x plus 2 is this polynomial factored. Okay, you can't simplify it any further because 5 doesn't share any numbers other than 1 and 5. X doesn't share anything other than x and 1. X plus 2 have nothing in common other than 1. So this is completely factored. Alright, there is a possibility that you might not have completely factored it. Like say, what if you just thought to pull out the 5? If you only pulled out the 5, you would have x squared plus 2x. And I would tell you that's wrong. Let's just say you only pulled out the 5, x squared plus 2x. That would be wrong. Because what's inside still shares x. And that needs to be pulled out as well. Okay? They get a little bit more difficult, or more complex, but they don't get any harder. You simply follow the steps. Okay? Example 6 was 4x squared minus 6x cubed plus 14x. Okay, the greatest common factor numerically looks like it's 2. Would you agree with me? The greatest common factor as far as a variable, what do they all share? X. That's correct. Why do they all share x? Certainly this guy and this guy and this guy all have x to the first in it. But this guy does not have x squared in it, nor do these two guys have x cubed in it. When you're pulling out the greatest common factor, you're pulling out what's shared. Now, divide each piece into each location of the polynomial. 4x squared divided by 2x. So 4 by 2 is x squared by x. Okay, watch out, there's a negative. Numerically, negative 6 by 2, 3. Good. X cubed by x. I have it totally written wrong, don't I? That should be a 5. 5, 3, and x. Okay, so that should be x4. All right. 14 by 2. This is positive, so it's going to stay positive. X by x, 1. Does 2 and x share any other factors between themselves other than 1? No. Numerically, 2, 3, and 7? Nope. x4 and x2 do. but they don't share it with the constant. Therefore, there's nothing else that can be pulled out of this. Okay? There's nothing else that can be pulled out of this. All right. Example 7. This is the last one. And remember, this is all going to be on YouTube for you to check. Same steps over and over. Nothing has changed. Between 1 and 4 are all the same. 5 and 7 are all the same. Okay. Greatest common factor of 8 and 12 numeric is 4. Let's look at each letter. A squared and A. B and B squared. C squared and C. Great. All of that is going to get multiplied by the quotient of the division. 8 by 4 is A squared by A. B by B is 1. It disappears. C squared by C. Bravo. Negative 12 by 4. AA, gone. B squared B. CC, gone. There's your answer. Okay? I wrote it wrong again. How are you guys not stopping me? Okay. Somehow I'm not writing these correctly as I'm copying them. If I don't copy them correctly, please interrupt me. Should have had a square there because it should have had it up there. All right.